Welcome to the show. I hope everybody had a good time this morning. We learned a lot. I know I did. I had a chance to sit in on some of those discussions. It was very informative. I'm going to talk for a little bit on technology. We learned a lot this morning, and we'll learn more this afternoon about how to produce the alfalfa. And I'm going to hopefully give you a little insight on using the machines to maximize your profit as far as the technology aspect. After you get the alfalfa grown, you got to cut it and process it to get it up into a manageable commodity so that you can sell it. So we'll give you a few things that we can talk about right here. I do want to thank the Journal and Alfalfa Seeds for allowing us to be part of this presentation today. We really appreciate that. So there's a neat little saying right here. This is an anonymous saying. This is one of those, you never know where they come from, but everybody seems to know them. It says there's no higher quality hay than when it's still standing. So think about it for a minute. You've done everything right. You've looked at the fertilization, you've planted it to the right depth, you've selected the right variety, you've got the rain, and you've got a beautiful crop of alfalfa standing right there. It's top quality stuff. But what this means now is that once you start cutting, your quality starts to go down. The quality is the highest just before you cut it. Once you start it, this is going to kind of recreate a little bit of what was done here before, but the quality decreases. And for every day that you have that hay laying on the ground, every 24 hours, you decrease the quality content by 20% on a day-over-day basis. So the traditional concept has always been when harvesting earlier rather than later. As Don alluded to earlier, a lot of us do a 28-day cycle, and that's what we have been taught all through the years. We've grown up with that, and it works pretty well. As the crop matures, as Don said, you know, the more mature the crop gets, the lower the quality gets. We've seen the diagrams and everything. So the thing you want to remember is you want to harvest at the highest quality that you can get. One of the nice things about this new technology, and this is a technology advance for the low lignin varieties of alfalfa that are coming out, is that it opens up the window of harvest. So that if you've got some inclement weather coming, or if you've got some suspect weather coming up, and the crop is at 27 or 28 days and you're itching to get out into the field, well, now you have the capability of expanding that window out several days so that you can miss the bad weather and not miss the quality degradation on the crop. So that's a technological advance, and that's a pretty good thing. I want to talk for just a minute about the different cutting methods. Traditionally, what we've seen over the years, everybody grew up with a sickle mower condition. I'm sure that everybody out here knows what a sickle bar mower is and what a mower conditioner is. You know, we've all spent our time on an old H or a 40-20 out there pulling machines through the field. I'm going to brag a little bit. New Holland was the originator of the original hay-vine mower conditioner. Back in 1964, we were the company that made the design that combined the cutting and the conditioning into one operation, and that revolutionized one of the aspects of the industry. As the time has progressed, sickle cutting is still the traditional way to cut the crop, and there are a lot of people that do it. But what we're seeing is an increase every year in disc cutting technology. Two different methods to do the same thing. Sickle cutting uses a reciprocating action of moving the sickle section against a shear plate, which is the electric plate on the bar, working back and forth, cutting the crop over through that way. It's a good system. It's a traditional system. There are some limitations to it. Ground speed is the most visible limitation. Even with today's advances in the technology of the machinery, you're limited to a maximum ground speed of about 7 miles an hour on a sickle cutting machine. If you can start to get over that, then you start to overrun the sickle, and you start to have problems with the crop not being cut correctly. Disc cutting has evolved over the last several years. It actually started out back down in the southeast. We had this nasty little critter come in. It was imported in from South America. It was called a fire ant. And that's where disc cutting really got its traction, if you will. Because fire ant beds are, if you haven't ever been into the South, you don't know what a fire ant is, but it's a nasty little critter. And it waits It will attack you, but it'll wait till there's about 10,000 of them going up your pants leg, and then one of them blows the horn and they all bite you at the same time. So it's definitely an experience if you've never been bitten by a fire ant. But they also build beds, and they look almost like gopher mouths out there, but they're very moist. And it's very difficult to cut through that type of incision if you have a sickle mower conditioner. So that's basically why disc mowers were brought into the country, was to blast through that type of stuff. Disc cutting is an impact cutting design. Basically, we have a series of high-speed rotating discs with a pair of knives on them, wax through the standing crop, and it uses the inertia aspect of the standing crop to cut through it quickly, just like a rotary mower does when you mow the lawn. You go fast and you go quick. And you cut the crop before it has a chance to fall. Disc cutting technology starts out at about 6 miles an hour. When you're out there and you're really looking for advancement in ground speed, you can start out at about 6 miles an hour, which is almost the top gun on the segment technology. And then you go upward from there. We have guys out cutting 16, 17 miles an hour through these fields, and they're doing an excellent job through the field. So if you're a big producer and you have a lot of crop to cut and only a short harvest window to cut it in, this machine will get you through the field substantially quicker. Everybody says, well, how do I know how fast can I go? How many acres can I cut a day? So here's a quick little factoid for you. If you take the cutting width of a machine in feet, and you multiply that by the ground speed in miles per hour, and then divide that number by the number 10, which is a constant, it will give you the approximate number of acres per hour you can move through the field at 85% efficiency. And 85% efficiency is a real-world estimate of your capacity that you can actually work through the machine. So, for example, if you have a 16-foot machine and you're cutting at, let's say, 15 feet, and you're moving at 10 miles an hour, it's pretty realistic that you can cut 15 acres an hour in a real-world scenario. So you can move through the fields pretty quick. We've got a lot of guys that are cutting quarter section away with these machines now, and it's pretty common practice. So it's got a definite advantage as far as the capacity of the system. We talked a little bit, if you sat through the sessions this morning on the analysis, one of the things that came up was the digestibility and the ash content of the rations and the samples that were coming in. We make 3 different twist knives for our machines, and depending on the degree of the twist, it will make a difference as far as how much material is moved through the machine, and it will also make a difference as far as how much dirt may be ingested as well. Usually, if you're in a good, tall, standing crop, and it's a good, heavy volume crop, you want to go with a little bit more twist on the knife, a 14-degree twist or an 18-degree twist knife. If you're in a light crop, if you're in a short crop, then you want to go with a knife that's a reduced amount of twist, down to about a 7-degree twist. We make knives in all of those different acclimations. We also make serrated knives for just more conditioners. The serrated knife is a good choice if you're in sandier soils, because it gives you better wear characteristics if you're in those types of soil cutting conditions, or crop cutting conditions, not soil cutting conditions. If you're in crop cutting conditions where you have sandy soils, a serrated knife will work better. If you're in a little harder soils, the smooth knife will give you good wear characteristics as well. So you have a choice to do that. And we also make what we refer to as a rock knife. Now that knife is designed a little differently. It has a twist to it, but it looks more like a trapezoidal arch, an upside down trapezoidal arch. All of these knives are reversible, by the way. But the rock knife is designed such that if you impact a hard object out in the field, it won't be as prone to bending or breaking. Usually what I say is, if you're out there and you're growing alfalfa in your fields, you have a choice of a couple of different knives. But if you're out there and you've got some marginal ground and you're growing more rocks out there in the field than you are alfalfa, then you want to go with the rock knife because it'll give you better durability. Another technological advance that we have introduced this year on our machines, our pull-type machines and our self-propelled machines, is the Quick Max knife change system. What this system does for us is it allows us to cut our time down substantially over what we've had in the past as far as changing the knives. One of the things that we hear a lot of cases is that customers complain about streaks and strips out of the field. And in a lot of cases, we can go back and look at the knives, and the knives are worn very badly. And that's one of the primary causes of an uneven cut or an uneven stub in the field. The Quick Max system allows us to change the knives, to flip the knives or to change the knives literally in a couple of minutes. It's a spring-loaded knife retention system. There is a special tool that you use. Basically, you turn the knife, you turn the disc at a 45-degree angle, you can put the knife insertion tool in, push the spring-loaded plate down, and you can literally unhook the knife and flip it or replace it in less than a minute. You can run the whole cutter bar on the machine. We have a 19-foot machine out here. You can run that 19-foot cutter bar in under 5 minutes as far as flipping the knives. So the reason I'm saying this is because the excuse has been in the past that the knives are so hard to change, I'm going to run them until they're just to the point where they just won't cut anymore, and then I'm going to go change them. Now, we have taken that excuse away. So there isn't any reason that you can't run sharp knives on your machine. Right? So that's a nice advantage there. It is an optional system, but we can fit it on these machines. The next thing to talk about is after you cut the crop, you've got to condition it. We make a couple of different variations on the conditioners. Primarily for legume crops, we want to go with a roll-type conditioner system. Grass crops, if you're doing exclusively grass crops or predominantly grass crops, you might consider a flail-type system because the flail system is a more aggressive system by design. So that would be a system to look at if you're doing more of the prairies or the fescues or the brooms or those types of things. But for legumes, roll conditioning is the best system to work with. We have a couple of different variations. The rubber-on-rubber conditioner rolls have been the best choice for alfalfa, bar none. They give you the capability to put a good crush on the stem so that the moisture will exit the stem. At the same time, we can adjust them to the point where the leaves pass through the gap between the rolls so you can minimal damage to the leaf. Far and away the best system that's out there as far as that. We do also make a set of steel-on-steel rolls. Now this slide, I have to tell you, this slide is just a little bit of a misnomer here because it looks like we have one rubber roll and one steel roll, and that's not what we offer. We offer a set of rubber rolls or a set of steel rolls. All right. This is just a picture to show the two different designs. Steel-on-steel is usually recommended if you're going into high tonnage crops, if you're doing hay grazer, for example, or if you're doing the sorghum Sudan crops. If you're doing if you're cutting in abrasive soil conditions, sandy crops or like that, or if you have a lot of rocks, a steel-on-steel roll is going to be more durable for you as far as the overall longevity of the roll. You can get a good crimp on the stem so you can get the moisture to release out of the stem. It takes a little bit different adjustment. It's not a hard adjustment to do, but it is something to be done. The roll system is the system, like I said before, to use for legume crops. And basically it's a function of gap and pressure. The higher volume of the crop that you're putting through, the more pressure you want to put on the roll, and the higher the tonnage of the crop, you want to change the gap on the roll. So if you're doing 20-ton triticale, you might want to increase the roll gap just a little bit. If you're doing half-ton alfalfa, I want to squeeze that roll gap down to the point where I can just barely see through it. And that way you still get the capability to crush the stem, but you're not going to do the damage to your roll. That's what you're looking for. Okay? Another thing that comes into play is after you cut the crop and after you condition it, you have a choice of putting it into a swath, or you have a choice of putting it into a windrow, or a variation there between. Independent university tests have shown that if you lay the crop, and this is specific to alfalfa and clovers, legume-type crops, if you lay the crop in a wide swath, you'll improve your dry down rate. One of the things that we talk about a lot with customers when we do cleanings is, I get a lot of problems. I have hay that bleaches out on the top. I can't get into the crop as quickly as I would like to. So when we quiz them about it, it's like, well, how do you do this? Well, I put it in a really tight windrow. I lay it right out. I don't want to touch it after I get done. And again, this is a cultural thing. This is the way we've always done it. But what we found is, or what the university studies have found is that if you lay the crop out in a wide swath, you'll gain dry down and efficiency. And in some cases, if you look at the graph up there, you'll see that when the crop is cut, it's going to be about 80% moisture. And as the crop dries down within the first 8 hours, during the sunlight hours, you're going to drop down to below about 40%. Then as you go through the night, the crop regains some moisture from the dew. And then as you go down through the second day, you're going to drop down when this crop is laid out in a wide swath. So at the end of about the 32 to 34 hours, about a day and a half, if your crop is laid out in a wide swath, you should be able to get in there and get it put up. If you put your crop in a tight windrow, a narrow swath or a narrow windrow, you'll see that at the end of that first 8 hours, you've only dropped about 20% moisture. You drop a little bit more, but then we have to go through that whole second day, and then through the second night, and then down to the third day before we can get down to about 20%, which is where we're going to be when we're baling. So just simply laying the crop out in a wide swath to start with will gain you time in the field. So if you've got a lot of hay to bale in a short time to get there, consider putting the crop out in a swath. Now the trick is to figure out when you want to put it up into a windrow. On legumes, the crop loses moisture from the leaf down to a point of about 40% moisture when it's in a wide swath, because the leaf is excited by the sunlight as it comes down. So as long as that leaf is stimulated by the sunlight, you're going to lose moisture. Down to about 40% moisture, that's where the primary means of moisture egress is in the plant. Once you get below 40% moisture, the leaf, the stomates in the leaf close, so you don't lose any moisture from that point. And now, the primary means of egress becomes the crush in the stem. So that's where the remaining moisture comes. So the trick is to get in there at about 40% moisture. If you're laying it out in a wide swath, you get in there at about 40% moisture. That's when you want to rake, because you're still going to have enough stickiness, if you will, to the plant to hold the leaf in place on the stem. You can roll the crop up into a windrow, and at that point, the stomates close. You're not going to lose any more moisture from the leaf, but the wind comes through and it allows the moisture to escape from the stem. So that's a more efficient way of doing it. That will give you some additional time and you'll be able to get into the field quicker. So now we've got the crop rolled up, we're ready to bale. So there's a couple of different ways to do it. Talk just very briefly about bale density. Dense bales preserve quality. You've done all this work to get the crop down, it's at the right moisture content, now you want to put it up in a package that you can handle. So you have a choice of small squares, you have a choice of round bales, you have a choice of big square bales. Any one of those systems works great. Specifically to round bales, what we would like to see is a bale that's very dense, because a dense bale stands up and it'll shed water better and you won't lose as much out of the bale. Now if you think about this, if you look at a 6-foot diameter bale and you go from the middle of the bale to the outside diameter, the first 3 feet from the middle of the bale comprise about 25% of the weight of that bale. The second 2 feet comprise about 25% of the weight of that bale. The last 12 inches on the outer shell of that bale comprise 50% of the weight of that bale. So if I don't store the bales right, or if I have soft bales, and I store them down on the under the tree line where the water drips down on them all winter long, and the snow drips down on them all winter long, I could lose as much as 6 to 9 inches off of the outer shell of that bale if it's not tight and it's not wrapped well and it doesn't have the ability to shed that water. Now think about this for a minute. If I have a 2,100 pound bale and I put it up and I lose 6 inches off of the outer shell of that bale, how much weight have I lost in that bale? You lost 25% of that weight of that bale. That's exactly right. So on a 2,100 pound bale, I've just lost 700 pounds just because I didn't make it tight. All right. So the next thing that comes up into play is if you're doing round bales and you're storing them outside, you want to remember 2 things. You want to put them in an area that's well drained, and you want to make a tight, dense bale. You want a bale that's at least 10 pounds per cubic feet, and more is better, because the tighter that bale is, the better it'll shed the water. and the lead stick will squat. So you reduce the footprint on the ground where the moisture draws up in from the bottom, and you allow the bale to shed water better. A couple of different things we've got for quality. We have a system called Crop Saver, and we also have Crop ID on the system now. The Crop Saver is a preservative application. You can have a couple of different aspects of this. We have a manual system and we have an automatic system for the Crop Saver application. Two different ways of doing the same thing. The automatic system uses a moisture tester that's mounted right on the baler, and it works very well. It's accurate to plus or minus 2% of the actual weight or the actual moisture content of the bale on a bale-to-bale basis. And that system will be able to turn on or turn off the preservative applicator as needed as you go through the field, because we all know that the bottom ground holds moisture longer than the top of the hill. So you may not need any applicator preservative on the top part of the field, but you might need a lot down on the bottom. The automatic system does that for you. The manual system, basically, you turn the switches on or off as you're up there in the tractor. So it's not as efficient a system, and you might use more preservative than you need. All right? So that's one of the systems. We also have what's referred to as a Crop ID system. That basically gives you the capability now to label each bale. This is done on the big square bales. It allows you to label each bale with the date, the field, depending on what you've got, whether it's if you have the bale scale on the machine, you can put the weight of the bale on, and about 6 other different things. So you can sort these bales out on a field-by-field basis. We also have a new technology now. It's called Crop RFV, which allows us to actually add the RFV number into the system. Now, this is kind of evolving, because we found out this morning that the RFV is not necessarily the best number to have on it, but it's better than nothing. So we're there, but we're kind of moving forward with that. But what this allows us to do is to actually tag these bales, and you can sort these bales by that number as well now. And what it does for us, we have a optional bale weight kit, and we have the moisture sensor kit. It takes these numbers and it uses an algorithm, a mathematical algorithm, to go ahead and calculate the RFV value of that bale on a bale-to-bale basis. What we do beforehand is we go out and we take a representative sample of the field as soon as it's cut, send it to the lab, they come back with the RFV number. We program that number into the controller on a foundation basis, if you will. And from that point on, as they look at the moisture content and they look at the weight of the bale as it comes off the baler, then it's a calculated value that puts, But it's pretty darn accurate. It's one of the top systems in the country as far as accuracy on a bale-to-bale basis. It allows you to pre-sort the bales out there. You can put them up into sheds. If a guy wants 180 RFV, hey, you can go that way. If you want 150, you can go that way. And you've already got it redone. So it gives you a little bit of an advance and a little bit of easier system approach to it. We also now are coming out this year, for 2016, coming out with what we refer to as IntelliCruise technology on these machines. If you have a tractor with a CVT transmission, we now have the capability to let the baler basically drive the tractor. And what this will do for us is it will allow us to put 2 different variations in. You can count the number of strokes per bale, if you're looking at a specific number of strokes per bale, or you can count the thickness or the charge of the bale. So if you want an even flake thickness across the bale, you have that capability as well. The baler actually senses the amount of feed that's coming through with a set of eyes in the feeder assembly down in this area right here. It senses the thickness of the feed rate of the windrow, goes through the controller, goes through all the magic smoke up at the top of the controller, comes back out, sends a signal to the tractor and says either upshift or downshift to maintain a uniform feed rate going through the baler. The nice thing about this is that if you're out baling and you're baling 16 or 18 or 20 hours a day like some of us do, at the end of that time frame, you're going to get the same consistency of the bale weight and the bale length as you did at 8 o'clock that morning when you started out. And you can't do that with just us humans up there sitting in the tractor seat for 16 or 18 hours. As we get tired and fatigued, our efficiency goes down. The controller doesn't do that. So that's a nice advance. After we get done, we have a little thank you calendar, or a little thank you book that you guys are going to get. The bag is going to be given to you after you fill out your little forms. And if you look at your kits that you got this morning, one of those forms in there is a essay as far as telling how everybody did today. So when you fill that form out and you turn it back in, you're going to get a little thank you bag out there. And one of the things that's in that thank you bag is the copy of the Haymaker's Handbook. This is the 3rd edition of the handbook. It is an excellent reference point for a lot of the things that we're talking about. Now, it talks about everything from the ground up: fertilization, liming, seedbed preparation, seed variety selection, machinery system matching, so that you can match all of the inputs in your system to maximize the efficiency of the system out there, and storage. And at the back of the book now you're going to have some additional stuff in there as far as nutritional information. If you're feeding cattle, for example, or if you're feeding the horses, those types of things in there. It's a very, very good reference point. It's written in pretty simple language, even I can understand it, so that's a good thing. So it's a very easy book to understand. That'll be part of that in there. So that's kind of one of our little gifts to you guys for coming and attending and putting up with this presentation this afternoon. All right. With that, I'm going to turn it back over to Holly. Thank you very much for your time and attention. I appreciate it.